at least? Nice. Yes, bats and dragons. Anyways, you all know all of these, so we're going to go through them very quickly because you know them to death. But of course, applying them is always the problem, right? Applying one at a time, everyone's like, oh my God, so easy. But when you get to the tough question, you have to apply all 7 of them in one question. All of a sudden, nobody can do anything with exponents. It's always my worst unit. I don't know why. I think I do a good job of it, but I have never done a good job of it because I have never felt like my students really get it. Because it is always the worst unit. Now, when I say the worst unit, I mean the class average is like 72. Which, is okay. But I'd like to see it higher. All right, so multiplying powers of the same base. We talked yesterday. We went over this whole sheet. We talked about it all. If they're the same base, let's go x squared. Now, again, don't yell out the first thing that pops into your head. What does this mean? Okay, I'll change the question. What's the answer? X to the 5th. Why? Now, this is where think about your answer. Why is it x to the 5th? Okay, that's the shortcut. That's what you do. And if you memorize 7 shortcuts, you'll get through. You'll get the 72%, right? We need to know what we're actually doing because when you stack up 7 of these laws in one question and you're like, oh, do I add, subtract, what do I do? Right? When we're doing the notes, let's remember what's actually going on because this is really x times x times x, naughty, times x, which is how many x's? X to the 5th. Because math people are lazy, they would never write that, yes? And then, of course, now we can do the rule that Sophia has already reminded us of, x to the m times x to the n. So any base to any exponent multiplied by the same base to the same exponent gives me x to the m plus n. Remember, the base doesn't change. Okay? Okay, and you already know all this. Like I say, we're going to go through this fairly quickly. Dividing powers of the same base. X to the 5th divided by x squared. What is that really? That's the answer, but really, it's x to the 5th over x squared, yes? And what do I get to do with these x's? Cancel them. When they cancel, do they disappear in reality? No, what do they become? Ones. 1. Now, do I need to write 1 times 1 ever when I'm multiplying? No, so we're left with x cubed. And of course, the rule is x to the m divided by x to the n equals x to the m minus n. Now, that's easy, right? No problem. Everybody gets it. And then I do this. You don't need to write down what I'm about to do. I just want you to look at it. 3x squared times x to the 4th. What's that answer? 3x to the 6th. Because the exponent law only applies to the exponents. Everybody cool? Okay, again, you don't need to write these down. This is just layers that can be added to this simple law that everybody wanted to say, add the exponents. But you can add layers to it that make it more complicated, but not more difficult. What then is 3x squared times 4x to the 4th? 12x to the 6th. Lovely. And finally, what is 3x squared times 4x to the 4th? Y. $12x to the 6th y. Right? Easy peasy. That's law 1. Law 2. X to the 7th over x to the 3rd. What's that? X to the 4th. 4x to the 7th over x to the 7th over x cubed. Not x cubed, x cubed. 4x to the 4th. 4x to the 7th over 2x cubed. 2x to the 4th. Excellent. And lastly, 16. No, 16 is bad. I don't want to do 16. 15x to the 7th over 9x to the 3rd. See what I mean? It's supposed to be easy, right? 5x to the 4th over 3. It's all the same laws, right? But already in the very first question, just saying, oh, you subtract the exponents isn't enough, right? We got to know what we're actually doing, which means we can't forget stuff from grade 3. Go. Simplified the fraction. Yep. Because this is really, and you'll hear me say that a lot, what is this really? This is really 15 times x times x times x times x, right? Over 9 times x times x times x. Oh, 3 more x's there, right? And then we would cancel those 3. So there's our x to the 4th. And then 15 over 9, we would never leave that as an answer because Mrs. Bad Crumble would mark it wrong. And we would simplify that to 5/3. Right? Okay. So those are the first 2 laws. Everybody's cool with them. Good. But please notice, as I was saying, you think you're in perfect shape, right? Oh, I've got the laws memorized. It's easy peasy. And then I make a very slight change to them. And all of a sudden, the first question, 30 kids answered. X to the 7th over x to the 4th. X to the 3rd. The next question, I had 1 layer. 5 kids didn't answer. By the bottom one, it was everybody answered, but it was more like you were asking me the question, right? 5x over 3? See the difference? But it's the same law, isn't it? Okay. Raising an exponent to an exponent. Oh, I have a joke. In the first block, my students were saying that there wasn't a lot of notes on the screen at one point. Right? And I said, oh, that's because I've magnified it more than usual because of a student in my other class. And I said, it's very ironic because it's year 2020 and she can't see. Get it? I know, right? When I woke up on January 1st, I was like, I'm going to throw away my glasses. It's year 2020. And then my wife punched me in the mouth. She didn't really. It was a metaphorical punch in the mouth. She doesn't like my dad jokes either. But I'm a dad, so by definition, every joke I tell is a dad joke, be it good or bad. It's a dad joke. Has to be. Anyways, back to math. X to the 3rd squared. Again, you all know the answer. What's the answer? X to the 6th. Why? Because it's x cubed times x cubed, which is really xxx times xxx, which is x to the 6th. And then the shortcut is, of course, x to the m to the n equals x to the m. I shouldn't have drawn the box first. M times n. Yeah? And that rule links up very nicely. This one, actually, I don't want to do that way. So, again, real quick, x squared to the 4th is what? X to the 8th. 2x squared to the 4th is 2x to the 8th. 2x squared to the 4th is 4. 16x to the 8th. Right? Same thing that just happened before, right? Everybody, most, be careful. Fraction base with an exponent. We already know this one. A fraction base, x over y. Because if it was x over x, it wouldn't be a fraction, would it? These would have to be different. Squared is what? Absolutely correct. X over y times x over y, which is x times x, xx over y times y. We would never write xx, x squared over y squared. And the rule is, of course, x over y to the m is xm over ym. Now, this is where I start saying, at this point, most kids start kind of forgetting about 1, 2, and 3. You can't. They're all together. So what I mean by that is if I go to something like this, x to the 5th over x to the 3rd squared. And right here is where exponents start to get difficult. I shouldn't say it, wrong word, start to get complicated. Because from here, I could draw step 1 going this way, yes? But I could also draw a step 1 going this way, because there's 2 different things I could do to start this. This is a really, really simple question, but already I have 2 different paths I can go down. So if you don't know what's going on, you can be in trouble. And there's no way I can teach you all the paths, especially on complicated ones. So would anybody like to tell me what they would do first with this question? Toby, what would you do first?
I would put the squared into the 5 and 3.
You'd bring this in here.
Yeah.
So you would have x to the
10th.
x to the 10th over
X to the 6th.
x to the 6th, because that's what we just did in Law 3, right?
Yeah.
And if we follow Toby's root idea, then obviously the next step would be Law 2. Subtract these exponents, yes? And you would have x to the 4th, right? Now, would it be just as valid to do x squared, and then x to the 4th that way? I get the same answer, don't I? I'm applying the same laws. The problem with this is, even in these simple ones, if I just start working on it, and I don't take the first step that you take, and it's a really long one, you will, I don't know what I'm doing. But you do know what you're doing, right? I'm just applying a different law at a different time. Everybody with me? Okay? Now, eventually, I'll write a question here, and there could be 9 first steps. That'll be okay, because eventually, if you apply all your laws correctly, we're going to end up at the same place. Yeah? Excellent. Exponent is 0. So I've given you 4. An exponent is 0. I throw this one in here because it's the one that lets you relax, right? Oh, I'm starting to get tense. Oh, but this one, I got this one. What is the exponent of 0? No, it's not 0. What is it? 1. Right? Why? But why? If I have x cubed over x cubed, aren't those the same things? And anytime you have the same thing in the top and bottom of the fraction, you divide it, you get 1, correct? Well, what do I do with exponents with the same base and I'm dividing? Subtract. So isn't that x to the 3 minus 3? Which would be x to the 0, which, if that equals 1 and that equals 1, then that equals 1. Okay. Now, again, though, it's not that simple, because what is this answer? -1. What is this answer? This is +1. Right? Everybody with me? Because the negative is part of the base. Any base to 0 is 1. Any base. What if I wrote 7,375,852 to the 0? 1. It's always 1. But is this negative part of the base? No. So this is negative 1. Cool? Okay. Now, this is where things really go in the toilet. And I don't know why 6 is there. These two should be reversed. I'm going to come back to 6. Let's get 7 out of the way because that's a super easy one. Xy squared is just like exponent law 4. What is the answer? That's xy times xy, which is x squared y squared. Right? So, of course, the rule, xy squared. No, not xy squared. Xy to the m equals xmym. And, of course, all other rules apply. So we already did one, the last one we did with when Toby gave us his first step. We had x cubed over x something else, I don't remember, y squared all to the third. What's that? I have to remember exponent law 3 and exponent law 7 now. It is x to the 9th and y to the 6th. What if I add this 2 here? Now what do I have to add here? 8, because the 3 has to go to the 2, and I get 2 cubed, which is 8. Everybody still good? Everybody's good. Okay, so now, again, you can write this down or not. I'm going to do one question that has everything we've done, but no negative exponents. Okay? That a 5, that a 2, and I'm going to square the whole thing. That has every single law that we have talked about in it. If you want to write it down, go ahead and write it down. If you just want to think about it and not, waste thinky time writing it down, that's cool too. It's been recorded. You can get it later if you want, and you're going to do a ton of practice. So I almost recommend not writing anything down right here because there's a ton of practice coming and just thinking about it. This is what I was talking about earlier. I can see right now 1, 2, 3 different ways I could start this. Personally. I know the one I would choose, but it might not be what you would choose. Anybody want to say what they would do first? Haley, what would you do first?
Probably get rid of the outside.
You'd get rid of this too? Yeah. Okay. Now, that's fine. My argument there is watch what I have to do. That 2 needs to go there, right? Yeah. And it needs to go there, right? Yeah. And it needs to go there, right? Yeah. And it needs to go there, right? And it needs to go there, right? And it needs to go there, right? Yeah. I got to draw 7 lines in my head if I'm going to do that step first. Now, I'm going to borrow from Toby, who gave us the last time. He worked out the inside first. 6 and 4. What happens there? 3 over 2. Thought 3 and 1. What happens there? That guy disappears, and how many of these guys disappear? 1 of them, so that is x squared. What happens here? These guys disappear, 3 of them disappear, and now I got y cubed. Right? And now I can square. Less work. Right? Is your way wrong? Absolutely not. You'll get there. It's just more. Right. Bea. We're getting to that. That's law 6. That's negative. Yep. Yep. Well, the reason I did that here is because of this. So this was 5. This was 3 and 5? 3 and 5, and this was x and y cubed, right? Okay, so up here, really, y squared, thank you. I changed colors there, I didn't mean to do that. Y squared. So up here, really, Bea, is x, yes? And down here is really x, yes? So that's going to cancel, and that's going to cancel, leaving me with 2 x's on the top. With me? In the numerator. Same thing here. I got 5 y's and 2 y's there. So what's going to happen to those two? They're going to be gone, and they're going to be gone. And I'm left in the numerator. Now, what you're asking about is when there's negatives involved, which is what we're about to do. I'm about to remind you about negative exponents. So, and then, of course, we'd finish this one off with 9 x fourth y sixth over 4. And I'd be done, because 9 and 4 gets no simpler. Okay? That's everything we've reminded you about exponents in the whole year in one question. And most of you seem okay, yeah? All right. So now let's go to where everybody gets screwed up. Negatives. I'm going to show you why it works, but I didn't leave you a lot of room because you saw this in grade 9, hopefully. You definitely saw it in grade 10. So I don't need to spend a lot of time on why it works. This is one of the rare times that I'm going to spend more time on what you do. Okay? So let's start with why it works real quickly. 3 squared equals 3 times 3 equals 9, which is technically 9 over 1. Right? 3 to the 1 equals 3, which is technically 3 over 1. Right? And lastly, 3 to the 0. Can't write it. It equals 1. Technically 1 over 1. And the relationship here, each time, when I go up an exponent, I add a multiplication, yes? So when I drop an exponent, I'm dropping a multiplication, which is division, right? 9 divided by 3 equals 3. 3 divided by 3 equals 1. So logically, the next step is 3 to the negative 1. Logically, I would take 1 and I would divide by 3, and I get 1/3. Right? And then, logically, 3 to the negative 2, I divide that by 3, and I get 1/9. And you should be seeing the pattern. 3 squared is 9 over 1. 3 to the negative 2 is 1 over 9. It's just a reciprocal, which should be enough, right? Everybody should be okay with that, because I go over here and I draw this law, and everybody's cool with it. X to the negative m equals 1 over x to the positive m. What kids don't remember is, obviously, what if I reverse this? If I have 1 over x to the negative m, that's not allowed because I can't write it out. I cannot write x negative m times. So this becomes x to the positive m, because that is technically x over 1. Everybody cool? I got to do one more thing, and then I'll show you. Which, of course, means, what if I have x over y to the negative m? Well, I know from law 4 or 5, this m has to go to both of them, yes? Which would give me x to the negative m over y to the negative m. Negative m isn't allowed. I know that that becomes x to the m down here. And I know this x would need to come up, so this y would have to come up. I must reciprocate for the negatives. Do I reciprocate for a negative base? No, of course not. It's only for exponents. Everybody good? Now, your next page is work, but I don't want you to go start work yet, because there's weird stuff that happens with these negatives, and I want to show you them first. And again, I really recommend not writing this down. I recommend just thinking about it, because you're going to get a lot of practice in a minute. Start with an easy one. X cubed over x to the 6th squared. What would we do? Pardon me? Yeah, you could apply the 2 here, no problem. That's going to be x to the 6th over x to the 12th. Then what? Subtract x to the negative 6, easy peasy, 1 over x to the 6th. Now, what you were talking about earlier, Sophia, it was Bea, when I was moving stuff around, if I'm doing this in my head, I don't think about add, subtract. I think about what's actually happening. I don't see x to the 6th. I see x, 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 x. Like 6 of them. That's what I see in my head. And then I see 12 down here, which means those 6 are all going to disappear, and 6 of them are going to disappear, leave me with 6 on the bottom. So I can go right to here. Okay? Everybody cool? Sophia?
So if you start with a negative exponent or whatever, to flip it, you end up with a positive?
Yes.
Okay, so you're always going to end up with a positive on that?
You have to finish with a positive one. So that's one way to do it. Now, what if this happens the other way around? So for example, I have something like this. X to the negative 3 over x to the negative 6 all squared. Now what am I going to have? If you want to simplify in the 2, you're going to have x to the negative 6 over x to the negative 12, right? Where does that negative go? But it has to move down here, yes? And where does this one go? Up top, x to the 12th. And now, what's 12 minus 6? Everybody good? Now again, that's not how I see this. I see this as, okay, I've got negative 6 there and negative 12 there, right? So I can get rid of negative 6, which leaves me with negative 6 down here, in a denominator, so I move it up to the numerator. Everybody good? Okay. And then finally, I want to talk about this problem. X to the negative 4y squared over x to the 3rd y to the 9th. Now again, if you get locked into, I'm going to do it this way, this one is going to get confusing. Right? If you are locked into, I got to get rid of that negative 2, I got to distribute it in, this is where it starts to get confusing. So what I like to do with these ones, when I have an entire base with a negative, I flip the whole base at the very beginning. Because I know a negative exponent is going to reciprocate eventually, right? So I know I'm going to end up with positive 2 because I'm flipping this. Now this is where kids make a mistake. They say, okay, I flip it. So x3, yeah, no problem. y9, no problem. They go up. X, what goes here? No. And that's where you kids screw it up. When I reciprocate, I'm only taking care of this one. So this is still negative 4. And this is y squared. And now it's a positive 2 out here. Okay? Now, you like to simplify inside the brackets, right, Toby? Oh, you like to bring the 2 in. Somebody wanted, at some point we simplified inside the brackets. That's okay here too, but if you're going to simplify inside the brackets, you don't touch this negative 2. So you might say, okay, well that is going to come down. There's already a 3 there. I'm going to bring that down. Now I have x4, y2, y9. Oh, okay, well that's x7. 2 of those are going to disappear, right? Which means how many of these 9 are disappearing? 2 of them leave me with y to the 7th. Can I leave nothing up there? That's not allowed because that would make it 0, yes? And this is obviously not 0. So there's a 1 there. And now I still have a negative 2 here. So now I could flip this, and then it's not confusing. Everybody with me? If you are going to flip right away, you got to remember nothing inside changes. You follow the same patterns. Now could I move this up here? If I was on this path, could I take this negative 4 and move it up here? Yeah. And then I'd have x3, y4. 2 9s on the bottom. Going to get rid of 2 of those there. y7. x3 and x4, x7, y7 squared. And I'm good. Over here, negative 2. What do I do with this? I reciprocate it. And I end up with x7, y7 to the positive 2, and I'm at the same place. I understand that this is frustrating. I do. Because if I take a weird step that you don't see, you feel like you're out of the game. But you're not. All right? That's the point of this. Haley.
Why is there a Y for? Is it in
Where? Oh, sorry. That's supposed to be an x. I'm sorry.
No,
X. X7, Y7. Sorry.
No.
So then you didn't.
Oh,
And then I combine the x's to get x7th, just like in law 1, right? And then this is now law 3, x to the 14th, y to the 14th, right?
yeah.
I should have used different colors. I'm sorry for that. This one, negative 2, will reciprocate this, right? And I'll get x7, y7 over 1. Do we ever write over 1? No, so it's gone. And this is now the positive 2. Then I distribute, and I get x14, y14, and I have the same answer. Everybody good?
Yeah.
All right.
When you want to write the x14, y14, or the x7, y7 too?
I'm sorry, what, Sophia?
Which was the final answer?
This. This is the final answer. You want it as with as few numbers as possible. That's our goal, always. Now, what was this section called? Exponent laws, yes? A law is always the same, agreed? So what if something looks weird? What if, just for fun, I gave you something like this? X to the 2x plus 7. Now, I told you were never going to do anything with variables in the exponents, right? That's grade 12. But I have some questions in your work that deal with this. I don't ask you to tell me, sorry, let's make that y. I don't ask you to tell me how to work with this. But if I were to multiply that by y to the 3x plus 4, what do you think you could do with that to make it look better? What? Yeah, exactly. Because this is the same as y to the m. I'll change colors. Y to the m times y to the n, isn't it? This is just an exponent. So here we would add them. We'd have y to the m plus n, right? So up here we must have y to the 2x plus 3x, which is 5x, and 7 plus 4, which is 11. And that's your final answer. Now, next year, you'll take this further and you'll find out what x actually is. But in grade 11, I just need to remind you that even if it looks weird, you follow the same rules. Sophia?
Would it not be 5x squared?
No, because we're adding, we're not multiplying. Now, what if I gave you this one? And again, just think about it. Y to the 1/2 and y to the 3/2. That's weird. What would you do with that? It's 2. Why is it 2, Ellie?
You add the top ones because the bottom is the same.
1/2 plus 3/2, because we add exponents when it's the same base. Y to the 4/2, which is y squared. Everybody cool? It's a law. You do it all the time, no matter what it looks like. What if it was something gross like this? Y to the 3m plus 7, and y to the 2x plus 8. What would your answer be? 3m plus 2x, because you can't put them together, plus 15. And you're done. Okay? They're laws. You do it no matter what it looks like. Next year, you'll deal with those m's and x's. But in grade 11, all you're dealing with is putting them together. Everybody cool? All right. I'm done, and you will have half an hour with which to work on pages 5, 6. Start with 5 and 6. What? Shut up, really? Son of a... No problem. So, wait, when did that happen? I thought we were on the same pages.
This one's 9, the exponent
Exponent laws
laws is 8.
was 8?
Yeah. Probably from the ice
All right, I'll fix that up. I'll make sure it's on their same page after this, after today. Actually, I'll take attendance and I'll fix it right now if everybody's okay for a few minutes. If you're not okay and you need me, go to the next question because I want to fix this. That's going to be a pain in both of our butts all year if I'm on a different page than you guys are. Yeah. You need to do the page that starts with simplify and rewrite and go until more practice at page. So that's not even in your book. Stop there. Okay, we should get that done today. We should be able to discuss some of it and make sure we're all doing it right. Yes, that's it. Nobody else goes till they're both back.